Okay, for our ice sculpture problem, here's all my work and answers, but this ice sculpture is melting away. And what this table represents is the R prime of T, like how fast that radius is changing. So that's the R prime of T, which is the same thing as dr dt, how fast that radius is melting away right there. So for part A, it says approximate R double prime. So to get from R prime to R double prime, we're going to do a derivative, which is slope. And the average rate of change is a slope formula. So we're just going to do the slope form between 7 and 10. So between 7 and 10, I just jotted down those 2 points as a couple ordered pairs. And then you just have to practice this without the calculator. Subtract the y's on the top, subtract the x's on the bottom. You're going to get this 0.2. And since you're going from a first derivative to a second derivative, it's going to have you're going like from a velocity to an acceleration, you're going to have that centimeters per day squared type of units, like for the acceleration right there. So there we go for part A. And it does ask for the units of measure there and show the computations lead to your answer there. So just show the work there like I did for you. Now for part B, it says, is there a time between 0 and 3 for which that R prime is equal to -6? Justify your answer. That sounds like theorem talk to me. And if I want to see, hey, is my derivative equal to something or is something in between a couple other values, probably going to end up using my intermediate value theorem here. And remember on your blue packet here, we got the intermediate value and the mean value theorem. I don't see first derivative is equal to 0. I do see derivative is equal to a number, but they're talking about this is given. So like if they gave me y's and said, show that y is equal to something, they're asking me to use the intermediate value theorem. So if they give me the 34th derivative up here and say, show that the 34th derivative is equal to something, like that thing is equal to something, it's going to be this intermediate value theorem. So my work here, I just mentioned R prime was continuous. All right. When they tell you to have a twice differentiable function there, everything's smooth and continuous, you just have to jot that down, because your intermediate value theorem, what that says is if you got a continuous function and 2 different y values, and k is in between those 2 different y values, there's some x value that is equal to that y value in between. All right. So if you have a y value of 2 and a y value of 10, you're going to cross through all those y values 2 and 10 if you have a continuous function right there. So I just jotted down it was continuous. And then they're talking about in between 0 and 3. So I said R prime of 0 and R prime of 3 was as -6.1 and -0.5. That's where I got these 2 numbers right here. Now it's asking, is that derivative is equal to -6? Now, if you have a derivative answer of -6.1 and -5, notice where -6 is at. -6 is in between the -5 and the -6.1 there. So that is the intermediate value theorem. So I just stressed -6 is in between there. We have a continuous function, and then you have to just jot down intermediate value theorem. So continuous, -6 is between those 2 numbers there. Intermediate value theorem guarantees a spot where it has to cross through -6. Okay, a right Riemann sum. You've seen this a bunch. We're going to rock these 4 subintervals indicated by the table right there. So right Riemann sum. So you're going to start at the right side of your table. This is your height. You're going to go -3.5 times the distance between 10 and 12, which is 2. And then you're going to go plus -3.8 times the distance between 7 and 10, which is 3. Plus -4 times 4 plus -5 times 3. And so that's where I'm getting these numbers from. And then you just got to be a little bit careful, because this is a no calculator problem. So if you notice, I didn't do all that in my head. I could do some of those in my head. I might probably be able to do all those in my head, but I just wanted to be extra cautious. So I kind of went to the side. I just did some basic arithmetic real quick, and was multiplying some things, adding some things right there. But just spend a few minutes and then just make sure you get those calculations correct there. And then make sure that you show your work there. So in case you happen to put something wrong, like, hey, you got all your work there. A left Riemann sum, just the pattern would be -6.1 times 3 plus -5 times 4 plus -4.4 times 3 plus -3.8 times 2. All right, the last one, we can handle this. All right, I know there's a big paragraph there, but we can handle this. We can approach this problem. The height of the cone decreases at a rate of 2 centimeters per day. This automatically sounds like a related rate problem, where I jot down dH dt is -2 centimeters per day. At t equals 3 days, the radius is 100 and the height is 50. So I just jotted down t equals 3, r equals 100. H equals 50. Find the rate of change of the volume. So you want to find dV dt with respect to time in cubic centimeters per day at t equals 3 days. And then notice it even gives you our geometry formula. So start with the geometry formula. Now, normally, this is like a level 3 type problem, and you have to get rid of one of those variables. This is not really a level 3 problem because you know stuff about R and H, you know the dH dt, and you need to find the dV dt right there. And also, if you're wondering, hey, I don't know anything about the dr dt, guess what, guys? Like this R prime of t is the dr dt, so they're giving us the dr dt. So we know stuff about the R and the H. It's perfectly fine to have those two variables in there. But when we take the derivative, since it's two variables, it's like doing a derivative like x times y's and stuff, okay? So when you do this derivative, we're gonna need to do the product rule. So this is a constant which just carries down, and then I have r squared times h. That's just like x squared times y, everything with respect to time. So we got dv dt, we got the first function, times the derivative of the second, the derivative of h times dh dt, plus the second function, times it by the derivative of the first, so the derivative of r squared is 2r, tag on the dr dt. Now we know r is 100, so I need to square it. So add in a couple of zeros there, just 100 squares, you're gonna have 4 zeros, 10,000. And then the dh dt they gave us was the -2. The h they also gave us was the 50. The r they also gave us was the 100. So I got 50 times 2 times 100. And the dr dt, we're at t equals 3. So I need r prime of 3. That is the dr dt at 3 is this -5 number right here. And so then I'm just trying to be careful with my arithmetic there and get this -70,000. And then they got this pi over 3, and it even tells you the units on that one. And so I got the cubic centimeters per day because how fast a volume is changing. So hopefully you feel pretty good about that one. Just study and let me know if you got any questions. Suit coat blazer.